This is 6.1. We're going to be doing area of various polygons, triangles, quadrilaterals. So if I had a triangle, and let's say it was our favorite Pythagorean triplet, 3, 4, 5, how would I find the area of this? Well, if that's a right angle, and I were to build a rectangle, the area of the rectangle would be length times width. We're going to call it base times height. So that would be 3 times 4, and our triangle is exactly half as big. So the formula is 1/2 base times height. Now, interestingly enough, if I were to move this point and slide it to the right, so let's say I slid this point to here, and then I drew the triangle, what is the area of that triangle? It's exactly the same. The base did not change, and the height did not change. What if I move that, if I keep going, and I move it over to here? The area is the same. So that area depends on the length of the base and the height of the triangle, and as long as that point travels along that parallel line on the top of the rectangle, the height is not going to change. So all three of those triangles have the same area. All right. What if I had a trapezoid? And this is not an isosceles trapezoid. Let's say one base is 10 and one base is 6, and the height was, say, 4. What is the area of this? Well, if I finished out the rectangle, then the area of that rectangle is simply going to be 4 times 10. Length times width, which we're going to say base times height. Okay. But our trapezoid is not going to be that big. It's going to be smaller than that. So what is the formula here? Well, I do have a rectangle inside there, right? So I'm going to call this base 2 because this is the bigger one. And I'm going to call this base 1 because it's the smaller one. So part of the area is simply base 1 times the height. And that would give me this. Right? What about the rest? Well, let's imagine we cut this out. And then we glued the two triangles together. So now I have this. How long is the bottom of that triangle? It's going to be 4. Everybody see that? The small base is 6 and the big base is 10. So the leftover for the big base is just 10 minus 6. So this is B2 minus B1. And how high is that? Still 4. So this triangle is 1/2 times 4 times 4. Okay? And then I would add that back. So 1/2 times B2 minus B1. And what should I do with those two areas? So this is the area of the rectangle, and this is the area of the remaining triangle. So the area of the trapezoid is simply base 1 times h plus 1/2 base 2 minus base 1. Oh, times h. I didn't put the h in there. Times h. Okay? Well, What does this have in common with this? They both have an H, right? So area equals, if I wrote it, H times B1 plus 1/2 times B2 minus B1 times H. I'm going to grab those H's and yank them out. So area equals H times B1 plus, let's distribute this, 1/2 B2 minus 1/2 B1. Okay, how does that simplify? So B1 minus 1/2 of B1 is H times 1/2 B1 minus 1/2 B2. What do those have in common? 1/2. So the formula is 1/2 H times B1 plus B2. The area of a trapezoid is simply the height times the average of the bases. Okay, so if I moved this 1/2 underneath here, the formula will make more sense. So let's redraw this, and then I can show you what it means. Okay. So we have a B2 and we have a B1. Well, instead of building my rectangle clear over here, what if I built my rectangle right there and right there? Okay. Then I can take this triangle, cut it off, flip it up, and stick it in here. And then I can take this triangle, cut it off, flip it up, and stick it in there, and I end up with this rectangle. Well, how big is that rectangle? It's H times, how big is the new base? Well, it's exactly half as, not half as big, sorry. It's exactly the average between the other two bases. It's larger than base 1 and it's smaller than base 2. In fact, it's directly in between those. It's halfway between the length of B1 and the length of B2. So B1 plus B2 cut in half. And that's where the formula comes from. You'll usually see it listed 1/2 H times A plus B. But I like to use the B1 and the B2 and move the 1/2. So H times B1 plus B2 over 2. You take the average of the two bases and you times it by the height. So we are creating a rectangle, but we're just kind of snipping half of those triangles off and then flipping them up and gluing them in. Okay. Let's do some Alex. Okay. Area of a parallelogram. Oh, wrong button. Sorry, guys. Here we go. Now we're ready. Well, how big is this parallelogram? Its base is 13 and its height is 10. So if I were to cut this off and slide it over and stick it right there, now I have a rectangle. What is the base of the rectangle? It's still 13. So the area of a parallelogram is simply base times height. Not base, not length times width. Well, I guess it's sort of length times width. But notice I did not use the 12. So in this case, 10 meters times 13 meters is going to give me 130 meters squared. Why do we say meters squared? If I divide this up into 1 meter squares and I counted them, there would be 130 squares that are 1 meter by 1 meter. So area is always units squared. Okay. Oh, that's not what I wanted. Area in the coordinate plane. So the vertices of this rectangle are 5, -3, 5, 6. Oh, thank you. 5, -3, and 5, 6, 2, 6, and 2, -3. Now, this is kind of funny. You can draw in the scratch area, but it's not part of the answer. So they're not going to grade your rectangle. Anyway, so this has a base of 3 and a height that stretches from -3 to 6, so that's 9. So the area is going to be 3 times 9, which is 27 units squared. And then the perimeter is simply going to be a pair of 9s and a pair of 3s added together, and that will just be in regular units because it's a distance. All right, area of a trapezoid. Here's that formula we were talking about. So we take the height and we times it by the average of the two bases. Which ones are the bases? The bases are always the parallel sides. So the height is 6, and the bases are 19 and 9, and the order of those is not important. We divide that by 2. Notice the 7 was not needed. So this would be 3. So 3 times 28, which would be 60, 84. 84 yards squared. Okay, moving on. All right, area of a triangle. I need a base and a height. I would recommend using lines that are parallel to the x and y axes. So I would call this the base and this the height. Otherwise, you're going to have to use Pythagorean theorem or maybe some trig. So the base stretches from -5 to 6, so the base is 11. And the height stretches from x equals 3 to x equals 7, which is 4, divided by 2. So that would be 22 square units. Okay. If it gave us a parallelogram, like this, and it wanted us to find the area. So the area of a parallelogram is just base times height. So the base would be 11, and the height is going to be 4. So that would just be 44 square units. Okay. Area of a rhombus. What do we know about a rhombus? Well, all 4 sides are equal, which means that each diagonal is cut into 2 equal pieces. This one tells me that WY is 14 and XV is 12. Now there are 2 ways to look at this. You can say that the rhombus has 2 equal triangles, or you could also say that the rhombus has 4 of those equal triangles. So find the area of the top half and double it, or find the area of one quadrant and times it by 4. So in this one, I know this is 14 and this is 12. This triangle right here has an area equal to 1/2 its base, 14, times its height, which is 12. But how many of these triangles are there? 2. So I'm just going to delete the 1/2, and the area of that rhombus is just 14 times 12 centimeters squared. Okay, so we've done trapezoid, we've done rhombus. Let's do kite. Oh, perfect. This is a kite. So in the kite, notice I have 2 equal triangles if I cut it in half that way. So if I can find the area of the top one and double it, that will give me the area of everything. This distance from x equals -4 to x equals 6 is a 10. And this distance from y equals -2 to 2 is a 4. So the area of the top is 1/2 times 10 times 4. But I have 2 of those, so I'll just get rid of the 1/2. That will be the area of the kite. Piece of cake. So here we have a rhombus PQ. This is 20. And PT, that is 20. And this is 16. Okay. So I'm going to need to figure out the length of TQ. So I have a right triangle A, 16, and 20. So A squared plus 16 squared equals 20 squared. So we subtract 16 squared. So 20 squared minus 16 squared is 144. A squared equals 144. So this is 12. Now I can forget that. The area of this triangle here is 1/2 times its base, 16, times its height, 12. And how many of those triangles are there? 4 of them. So we times that by 4, and it will give us the area in millimeters squared. Okay, that's it. Get to work.